Alright, Ramblers, let's get rambling. The purpose of this video is to talk about homework 13.8, help you out with the questions that we have assigned, provide you that extra help, that extra support, that one-on-one time, the working through the problems that frankly guys we just don't have time to do in class. So if you're watching this video, I'm assuming one, you've done your homework, and two, you're kind of searching for some extra help so you understand how to do the problems that were assigned to prepare yourself for that next test, that next quiz, that next assessment that's going to be worth a whole lot more than this homework could ever be worth. So let's get to work, boys and girls. So the first thing I'm going to do, we're looking at homework 13.8. You were assigned to do number 1 and number 2 on the front, number 2 on the back. So let's take number 1, but it's a 5-part problem. Let's take it one at a time. So allow me to kind of prepare my space. So this problem is unusual. They're asking you to solve for an equation, but there's no numbers. So we have to really kind of gain understanding of what it means to solve for an equation. If we're dealing with an equation, a formula like mx plus b, y equals mx plus b, and we're asked to solve for b, please note what that really means is that wherever that variable occurs, in this case a b that I'm trying to highlight in purple, what I need in the end, though in the final product, is that b on one side of the equation with everything else on the other. Now what this ends up being doesn't matter. The point being, if I want to solve for b, I got to get it by itself. That leads to a very natural question. Well, okay, so if I want to get b by itself, what's around b that I need to get rid of so that b is by itself? Now, when I say around b, I don't care what's happening on the left side. I need to focus on the right. So I'm looking at this b. What's around attached to it? What's around, or how is it attached to this b that I need to undo? I need to reverse. I need to unattach. Well, b's over here. I see an addition sign, and I'm dealing with this mx. Well, the mx itself is the only thing attached to the b. Okay. How is it attached? Well, it's a positive mx. It's being added by the b. Now, don't pay attention to this. That just tells you the b is positive. I'd pay attention out here. There's no negative sign, meaning that this is a positive mx. It's being added. Therefore, to undo it, I'll have to subtract. So, the property of equality, subtraction property of equality, states that if I want to subtract one side of the equation, to cancel, I need to also subtract this side of the equation to cancel. That will get me to the point where I can now cancel these guys out, leave myself just with this b. And on this side, I have to deal with the y equals mx. Now, this is something we stressed in class. We cannot execute this subtraction. They're all variably defined. I cannot take a y and subtract off mx. What I can do, however, is represent the subtraction. So what I'll end up doing is just really bringing the y and the minus mx down in a representative of subtraction, not actually executing it. Well, I said we're done when b is by itself. Well, b is by itself. This is your final equation in this case. So in this case, if you're looking, it was only one step, and these aren't as hard as people are making out to be. But in the end, we're done when we have the variable by itself. Now, what this purpose is over here? Now, this is going to be tough to answer. Now, what the purpose of doing this is writing the equation of a line in terms of b or in terms of y-intercept. If y equals mx plus b represents an entire line, simply switching it so b equals, well, that's still a line. It's a crazy form of line, but there you have it. It's a line. Let's take a look at the second one. So this is just dropping down a box. We're dealing with a equals l times w. So I'm going to rewrite it here. We're looking at solving for w. So again, what that means is we got to get w by itself. Well, the critical question remains: what is around w on the right side of this equation that we need to get rid of so w is by itself? Well, hopefully you guys are seeing that it's just an l. How is the l attached? Well, multiplication. How do we undo the multiplication? We divide. Division property of equality states if I do it to one side, I got to do it to the other for the explicit purpose of canceling one side. That w carries down because that's the only thing left. And again, we're in a situation where we cannot execute the division, but we can certainly write the division, a divided by l. We're done when that variable is by itself. It is. So that's my final simplified quote-unquote equation. Over here again, the purpose is going to be a little bit weird. We have to kind of look at this equation objectively. A equals L times W. Well, that probably stands for length. W stands for width. When I multiply those together, I get area. So simply moving this around is going to still find an area, but it's going to be finding the area in terms of the width. So if I have the area, I have the length, this allows me to find the width, hence what we solve for, of a rectangle. Or really any quadrilateral, but let's not get into that. Let's go to the third one down. So this is number 3. Please make sure you find in your paper, pause the video, whatever you have to do. We're dealing with this Mondo equation. V is equal to pi r squared times h. Okay, let's not get scared here. We're trying to solve for the h variable. I know it's some crazy stuff, but the steps at this point hopefully are becoming second nature. We have to identify the variable. In this case here, set h. Now let's ask ourselves that question, what's around h on the right side that we need to get rid of so h is by itself? Well, the only thing I see is a pi and an r squared, and those things are attached by multiplication. If it was addition, if it was subtraction, I see those symbols here. In this case, it is multiplication only. Well, how do I undo multiplication? Simple. How you do any multiplication? You divide. Now, I'm doing it all in one step. You could do them separately, but because they're all being multiplied to h, I can divide them all. That will result in a canceling. If I do it to one side, I must do it to the other. On the right-hand side, I'm just left with h. On the left-hand side, I have an unexecutable division problem, so I'll simply carry it down. Represents the division without actually carrying through the division. Hope you guys are kind of catching on that some of these problems really don't take that much to solve. It's just a moving around effect. Okay? Purpose, again, let's talk about this quickly. Finding the blank of a cylinder. Well, what are you solving for? I'm solving for h. H stands for height. Okay. Let's go to number 4. Okay, so number 4, P equals 2 times L plus 2 times W. They want you to solve, in this case, for L. So that's the first identify. Let's find that variable. Hopefully you guys are getting tired of this question. If it is, we're doing our job well. What's around L that we need to get rid of so L is by itself? This isn't so easy. Looks like we're going to have to deal in a couple different steps. The first thing it seems like we need to get rid of, or well, two things, I should say, that are around L that we need to get rid of. One is going to be this multiplied 2. The second is going to be this plus 2w. Now remember, in terms of undoing, we do the last thing that would be done first. So in other words, I'm not going to get rid of this multiplied 2 first. I'm going to deal with this added 2w. Add is the key word here. If 2w is being added to L, I'll undo it by subtracting 2w. Subtraction property of equality states if I do to one side, I must do to the other to maintain balance. These cancel, leaving a 2 times L on this side. Over here we have an unexecutable subtraction problem. I cannot take 2 w's away from a single p, but I can represent that subtraction by carrying it down. We're not out of the woods yet. We're still trying to solve for this L. I still have this 2 being multiplied, but I can undo that, I can reverse that, I can unattach it, because I know if I want to unattach multiplication, I divide. If I divide one side by 2, I must divide the other side by 2 as well. So the L is now finally by itself in the equation. On the left, I have an unexecutable problem. I cannot take p divided by 2 or p minus 2 divided by w divided by 2, so we can certainly leave it as is. P divided by 2w over 2. In terms of purpose, what are we finding? Well, let's go to the original. Like, we're definitely finding the L. That's what we were being asked to solve for, so we're looking at length. And the question is, well, what length of what? Well, P is perimeter, 2L plus 2W is what finds a perimeter. I'm going to say we're looking at a rectangle. Okay, let's take a look at the next one. So this is number 5 in the set. Now we're right back down to mx plus b, but they're asking us to solve for a little something different than the very first problem. So we're dealing with y equals mx plus b. They're asking us to solve for the x. So let's do our identify first. We're trying to solve for that x. Well, what's around it we need to get rid of so x is by itself? I see two things personally. I see this multiplied m, and I see a plus b. One thing happens at a time in reverse order, so we're not going to deal with the multiplication first, we're going to deal with the addition first. And of course, I know to undo addition, I'm going to subtract, which has to happen on both sides. mx carries down. We haven't dealt with that yet. B is cancelled. Y minus b, unexecutable, but we can represent it. Step 2, must get rid of the m because we're trying to solve for x. It's being multiplied, so certainly I'll divide it. Both sides. I'm left with the x on the right, y minus b over m on the left. Okay. So here we have writing equation of a blank in terms of x. Well, y equals mx plus b is a line, so it's still a line, but in terms of x simply means that's what I'm solving for. So kind of in summary, very quickly on this first part, it seems very much like we're just moving this equation around but still following the old rules. So like if you drop down to number 2, bam, number 2, we just have to understand what it's asking us to do, and I think you're going to find it's really no different than what we have been doing. We have this equation, 2x minus y is equal to 4, and it's in what we call standard form. Now, that's a review from last semester, but a standard form simply is an equation where you have the x and the y on the same side of the equation, and that's equal to a number. So we have an ax plus by equals c. That's all. That's just a form. It's unimportant. It's just that's what standard form means. But we have to translate it into slope-intercept form. Now, do recall slope-intercept form is y equals mx plus b. In other words, if I want to take this form, which is standard, and translate into this form, I really have to just solve for y. So in the end, what I'm looking for is to take this equation and translate it into a y equals something equation. I gotta solve for y. Well, if you just watch me do this 5 times, you know exactly what I'm gonna do first. Okay. I'm gonna look at my equation and I'm gonna ask myself, what is around y that I need to get rid of so y is by itself? I see 2 things. Now, here's where we got to be really careful. I do see this 2x. The question of how this is attached to the y is not subtraction. Well, it's not subtraction because this is a positive 2y. If that was a negative 2y with a negative sign out there, I'd say yes, you're subtracting the 2x. In this case, you're not because it's not a sign out there. It is a positive, so we're going to kill this guy by subtracting it. And of course, you got to subtract on this side as well. So what comes down would be a negative y. Over here, the temptation is going to be to say, I have a 2x here, or a minus 2x. This is an unexecutable problem. This has an x, this doesn't. This is 4, this is 2 x's. How can I take 2 x's away from something that has no x's? Trick question, can't do it. So what you got to do is just carry down everything. We'll have 4 minus a 2x. Unexecutable, you carry it down. Here's the last part. I have a negative y is equal to 4 minus 2x. Well, you might say, well, Mr. Collins, there's no number there. Well, there is a number. You don't see it because that multiplication doesn't matter. It's a times 1. So if I have a times 1 y, to undo a times anything, I'll divide, in this case by negative 1. Of course, if I do it to one side, I got to do it to the other. Multiplying or dividing everything by negative 1. Now, dividing by 1 doesn't change the value, but dividing by negative does change the sign. 4 divided by negative 1 will be a negative 4. Negative 2x divided by negative 1 will be a plus 2x. So that's the answer we're looking for. So slope-intercept form from our original, 2x minus y equals 4, becomes 4 plus 2x. Happy face. Okay. Very last one, staying sharp on the back. Now this is, again, pretty much what we've been doing. You have this equation, 8x minus 2y is equal to 24. And again, they're talking about standard form. Just keep in mind standard form is ax plus by equals c. Standard form just means it's an equation of a line where the x's and y's are on one side of the equation, the numbers are on the other. X's and y's on one side, numbers on the other. So you have this in slope-intercept, or I'm sorry, standard form. They want you to rewrite it in y-intercept form. Recall, this is y equals mx plus b. So what this really means is that we have to solve for y in this equation. This is something we have done together now for the last 14 minutes and 56 seconds. You know what's coming. So I'm going to split my equation. I'm going to solve for y. So I'm going to ask myself, I'll pause, what's around y we got to get rid of, so y is by itself. I see two things. Let's do the first thing first. We got to get rid of this 8x. How is that 8x attached to the y? It's not subtraction. It's a positive number. If it was a negative number, if it was subtraction, it'd be a negative 8x. It's not. It's positive 8x. So we'll actually kill it by subtracting, and of course subtracting over here as well. Don't be tempted over here to write a 16x. It's not. This has x's. This doesn't. You can't take 8x's away from something that has no x's. So we'll carry everything down. 24 minus 8x. Second part, well, what's left attached to the y? Well, I'm kind of seeing it times a negative 2, excuse me. So to kill that, we'll divide this by negative 2. Well, of course, if I divide one thing by negative 2, man, I got to divide everything by negative 2. So those will cancel, leave me with a y. The whole point of dividing was to kill these. Bam, kill them. Y is left. 24 divided by a negative 2 will be a negative 12. 8 divided by 2 should be a 4. Carry the x. Now here, look at this. Negative and a negative. That's going to be a positive. So 24 divided by 2 is 12. One negative keeps a negative. 8x divided by 2 is 4x's. Two negatives make it positive. So that's going to be my y equals mx plus b equation. Now the second part that kind of stuck in there is they want you to report the slope and y-intercept. Now this is an old skill, but a skill that we should maintain. In this equation form, the m is a slope and the b is a y-intercept. So if I'm looking here, there's my slope, there's my y-intercept. So they want me to report it. I shall. The y-intercept value is going to be negative 12. The slope value is going to be 4. Remember, it's just a number in front of the x, not the actual x itself. Alright, so that's it, guys. Now, this was a rather long video. I'll try to keep them shorter in the future, but the whole point is you wanted to see every problem that we assigned you worked out. That's going to take some time. So we always say the homework takes about 20 minutes. Well, there you have it. It took me 20 minutes to do. Alright, so with that being said, hope you guys have a great night. Hope you guys are working hard on this in class. If you have questions, be sure to comment those questions below. We're monitoring this. We'll respond to the questions. As you're working through homework for tomorrow, same deal. Make sure that you have everything asked and answered that you can. You guys have a great day. I will see you next time.